Let's get a quick understanding of all the different types of matchers which are available in JUnit. As we've already mentioned, matchers are basically static methods of the matchers class, which is part of the hamcrest jar that comes with JUnit. These static methods return something called a matcher object, which basically is capable of telling you whether a condition is true or not. These static methods are used in combination with the assert that method of the assert class in JUnit. So, using the assert that method, you can specify a condition that needs to be satisfied by an object and specify that condition using the static methods in matchers. So, lot of different methods exist in the matchers class. A lot of those methods are conditions which directly act on some object, and there are different matchers depending on the different types of objects on which you might want to check conditions. For instance, if you have a list object, then you can check a condition like has item within that list. Has item is a method that checks whether the value that is given in has item is present in the list or not. So here we have a list which has the rectangle's length and breadth, and we are checking whether that list contains the item 3 or not. Before this, we had set up a rectangle with length 4 and breadth 3. So this condition should be satisfied and this assertion should pass. So here we had a matcher method that was applying to a list object. Similarly, you have many other matcher methods which apply on different types of objects. For instance, you have all of these methods that apply on Java collections. For instance, you can check whether the collection contains a value or not. You can check if that collection has the same objects in a given order or not. You can check whether the collection has a specified size or not, and so on. Then you have methods like hasKey and hasValue, which, as the name suggests, basically check whether a map has a specified key or a specified value or not. So all of these different types of matchers for different types of objects are all defined explicitly in the matchers class in hamcrest, and you can use them directly. You can also write your own custom matchers for specific objects that you have created. We'll talk about that in another video. We also have matchers which work specifically with strings. For instance, here we have a different test in the screen, and in that test we are checking whether the statement "this is a test, it's a string" contains the other string test. So contain string is a matcher which works specifically on strings and checks whether a given string is present within another string or not. Then we have some matchers which work on all of different types of objects, such as equal to, which basically checks the equality condition between two objects. This is similar to assert equals. So assert that object equal to some other object is equivalent to assert equals. There's another matcher called is, which also is basically the same as using equal to. It will also check whether a given value is equal to another value or not. So here we had a bunch of different matchers which directly acted on a single object and checked that object for a condition. Now let's say you had a bunch of different conditions that you wanted to check on an object. Then instead of writing a bunch of different assertions or writing a complicated condition with or and statements, you can simply use a matcher which is present in the matchers class, which combines other matchers. For instance, here we have an assert that statement. It's pretty easy to understand this if you read it out aloud. Assert that a good life satisfies any of, contains string good, and equal to bad. So basically we have two matcher conditions here: contains string good and equal to bad. And the any of matcher is a different matcher method that is specifying that at least one of these conditions must be satisfied. So we combined the two matcher statements, contain string and equal to, using the any of method. You can use as many different conditions in any of as you would like and check whether at least one of those conditions is satisfied. And if at least one of these conditions is satisfied, the assertion will pass. Here, since the string a good life contains string good, even though it is not equal to bad, this assertion will pass. On the other hand, you might have another combining matcher like all of. All of basically takes multiple matcher conditions, and here it specifies that all of the individual conditions inside all of need to be satisfied for the assertion to pass. So here both of these assertions contains string bad and equal to good. Both of them will not be satisfied. So an assertion which calls for all of these conditions to be satisfied will definitely fail. You can check this by running this particular set of tests. So when we run this test class, all of the different test methods inside this test class will run. All of the tests pass except for the test that contained the all of matcher. And within that test, we get an error which is telling us that it expected a string containing bad and good, the words bad and good, but it got the string a good life. So here we got a clear reason why the assertion failed. This is a typical quality of matchers. Assertions which use matchers give very readable, articulate explanations of why the assertions failed. We'll see the benefit of this in the next video. For now, we've seen that there are a lot of different matcher methods, all of which have very readable names. So you can directly understand what the matcher is doing by looking at the name. All of these matchers are part of the matchers class. Some of them act directly on objects and some of them combine other matchers.